Uh, as we move on to our next slide, today's workshop, we do have ICC as well as AIA credits. After today's webinar, everyone will receive a certificate of attendance for this online workshop. And when you receive that certificate, if you could reply back with your ICC or AIA number, we will go ahead and file those credits directly with those organizations for you. So as far as our learning objectives, got a few today, obviously looking at the moving from the 2015 to the 2018 code, and going to identify some of the top 40 IECC compliance issues, as well as obviously looking with the objective of getting compliance with the energy code. So today's we are the Smart Energy Design Assistance Center housed at the University of Illinois, and our primary goal is to reduce the energy footprint of Illinois. That includes both public and private sector, and today's workshop is being provided in part by the Illinois State Energy Office housed at the Illinois Environmental Protection Agency. So as we move on to our technical support, we do have a line available. So if you do end up with some technical support questions for various projects on the Illinois Energy Conservation Code, then you can you can send us an email, energycode@sedac.org, or we do have an 800 number. Our preference is the email address, such that allows us a better ability to provide a more detailed response for questions that may come in. Our website does host several online resources, which include archived versions of previous workshops and webinars. We also have several online on-demand training modules that take approximately an hour to an hour and a half to complete. Those are designed for a little bit more of an introductory audience, so perhaps could be useful for building owners or occupants. So if they have questions about why do I need to go through this, you know, what does the energy code provide to me, that provides some good resources, along with several links that we'll talk a little bit more shortly. So on the next slide, talking about when the changeover happened from the 2015 IECC to the 2018 for the state of Illinois. It is for permits that were requested after July 1st of 2019. City of Chicago jumped a little ahead, so for them, permits beginning June 1st, 2019 used the 2018 International Energy Conservation Code as the basis for their energy code. So on our next slide here, we've got one of the biggest changes that we saw was for state-funded facilities, commonly community colleges and universities, along with several others. Previously, they were required to use ASHRAE 90.1, and so with this update that occurred this last year, they now have the same options as the rest of facilities across the state to use the International Energy Conservation Code or ASHRAE 90.1. So that was a nice benefit to give a little more flexibility. Something we do like to call out when we identify good practices is this is a document put together by the City of Chicago as part of their permitting process. So when you apply for a permit, you provide this compliance statement. One thing that we do like about this that we'll see on the next slide here is the lower portion here identifying which compliance path that we're choosing, which provides some great information for the code division and plan reviewer as far as what documentation to be looking for. So if someone here checks the com check box, then the plan reviewer knows to be looking for the ComCheck documentation and not necessarily the energy cost budget methodology. So this is a great, a nice tool, and so maybe beneficial to provide as part of your application, even if the city doesn't necessarily require it for that jurisdiction. So you can help them with their review. So we do have access to both the International Code Council webpage here, along with the State of Illinois documents and the City of Chicago's Energy Code. Again, I noted earlier, our website does have helpful links. And so if you go over to our website, sedac.org, and under our useful links section, you can provide get direct links to these documents. So rather than trying to remember the long web address, you can go to our website to pick these up for you. So as far as our previous webinars that occurred in this last or in the current year, we have 4 different webinars that have occurred, along with one that is upcoming. Those previous ones have been archived onto our website, so you can view previous recordings of that. And then our upcoming one is going to be touching on ComCheck and ResCheck on May 6th. So if you would like to register for that, you may go ahead and go on to our website and register for that. And we also have a couple of online workshops coming up. This is a 2-part series. If you can only attend one of the 2, depending on time of day, we understand these are being offered at 2 different times of day. You may go ahead and register for them. They will both be archived again to our website following the workshops. So even if you can only attend part of it, you can still pick up both parts at your availability. So, and with that, I'm going to turn it over to Sean, talk a little bit more about the commercial envelope and HVAC portions.
Oh, thank you, Ryan. So usually in our top 40 presentation, our full-length presentations, we'll cover these 10 sections for the commercial envelope. Today, we're going to cover the bullet point number 6 and number 7, air leakage through the thermal envelope and air barrier compliance testing. So let's dive right in. Air leakage through the thermal envelope. This is a requirement for the energy code that for air leakage testing is required for residential buildings, but for the commercial side, it's one of the compliance options. If you're going to do a full pressure test on a commercial building, it should be tested to a pressure difference of 75 pascals. And to comply with the energy code, your air leakage rate should be less than 0.4 CFM per square foot of envelope area. That square footage is not the floor square footage, it is the envelope square footage area. One of the things, blower door testing is very popular in residential because of that pressure testing requirement for residential buildings, and it's growing in commercial. We like to see pressure testing because it can reveal a lot of hidden issues that can otherwise be missed with the other compliance methods, which rely on plan review and on-site inspection and visual inspections. So even though it's not as common in commercial, it is a growing trend, especially in smaller commercial buildings. For very large commercial buildings, they either have trailer-mounted fans, such as the blower doors you see in this picture, or they'll use the HVAC system itself. They'll set it up to pressurize the building to meet those that 75 Pascal pressure testing requirement. To do that pressure testing, you have to seal all intentional openings in the building, so doors and windows have to be closed. For commercial buildings, it requires sealing off exhaust vents and things like that that would normally allow some leakage into the building, so that you can test the tightness of the envelope and not necessarily the tightness of your ventilation openings. One particular thing that we note in the past is on-site built fenestration can be particularly susceptible to leakage failures. Um, and a lot of times this results in down the road you'll see sealant fall out of place on those windows and things like that. So this is a really good way to catch those hidden issues, such as site-built windows or areas of the building that might have tight corners and things that are hard to look at. Moving on to the next compliance option, you've got air barrier construction and different compliance options here. The Energy Code specifies that for an air barrier to be in compliance, it has to be continuous across the opaque envelope of the building, and you have to be able to show that joints between dissimilar materials aren't going to dislodge or come apart over time. Penetrations through the building are going to be sealed with some kind of foam or a gasket. And one particular thing, recessed lighting, especially in awnings and things like that, has to have some provision, since the recessed can is ventilated for that light fixture. You've got a penetration through the envelope that then has to be somehow separated from the interior of the building. So a particular note there, that recessed lighting also has to have some design detail to separate that that recessed can from the interior of the building and break that potential thermal leak. In the pictures here, we show in order from the top left down to the bottom, moving right across those, the most effective and probably most expensive to the most difficult to get compliance, and probably most cost effective, least expensive. And they're also in order from least common to most common. Those fluid applied barriers are a great method to seal up gaps and stuff. It's a rubberized kind of adhesive. Self-adhered membranes are great because they've got an adhesive backing to them, so they seal to the building as long as you overlap them and follow installation instructions. You can ensure that all those joints are going to be covered and sealed together. But usually what we see on most buildings is house wrap or taped exterior insulation board where all the seams are sealed together. And with that many seams, it's often difficult to locate and find and ensure that all those seams have been sealed properly, especially when you've got joints between like those exterior wraps and window openings or other penetrations through the building. So we do like to see that fluid applied barrier, but the self-adhered membranes and the tape boarding and stuff are a little more common to see. One particular thing to pay attention to is complex building details. This is where a lot of our issues end up being with envelope air leakage. If you've got tight corners or odd joints in the building, they're difficult to reach. In this case, it's a patio over a sun patio area. There's a perforated roof deck above that, and the walls around that patio are supposed to go all the way up to the floor above and seal this patio area off from the inside of the rest of the building, because they have open plenum returns for their HVAC system and drop ceiling interiors. What we found was there's an I-beam that supports the outside rain screen structure, and I-beams that support the floor above on the inside. Between those, right above these patio openings, was an opening. And this was causing all sorts of issues with the HVAC system not being able to keep up. They had humidity issues in the summertime and heating and cooling issues year-round where they couldn't keep up with demand. Sealing those holes up fixed that problem. Another thing to be aware of that we see very commonly is drywall stopping just above drop ceilings, especially on exterior walls. It leaves an open pathway for anything entering that wall cavity to then leak into the inside of the building. Again, because ceiling plenums are often used as returns for HVAC systems, they're depressurized slightly, and so that draws in outside air directly into the building. Before we move on to the HVAC section, we have a poll question here. I'm going to launch that poll question. The question is, what is not an acceptable compliance method for commercial air barriers? So we covered the leakage testing, pressure testing for the building and pressure testing for materials and assemblies. While people are answering that poll question, we also got one of the questions in the Q&A is, do you usually see the outer sheathing layer go to the deck, allowing for attic ventilation? That seems to be more towards residential type construction. Usually attics are ventilated there. Most commercial buildings tend not to have attic spaces. Usually you'll have a drop ceiling with a flat roof deck. Usually what we see with the outer sheathing is it stops at the top of the wall, and then you've got the connection to the soffit for attic ventilation. Ryan, if you've got any input on that one.
Yeah, and I believe in some of your longer, or actually look at some of those photos where we see detailing where, yeah, it's not uncommon where you see the walls going up to the roof deck using a corrugated metal roofing deck that unfortunately where that corrugation in the wall meets has an issue not being properly sealed. So you might see locations where they've either stuffed some fiberglass or other air permeable insulation in there, which is not an effective air barrier. So again, as Sean noted, anytime you have dissimilar materials coming together or irregularly shaped joints, that's commonly where you're going to end up with a problem as far as getting an air barrier right. Getting a flat surface in compliance is much easier than the corners.
Okay, it looks like most people have finished answering our poll question there. Most people got it right. That first option is the residential compliance requirement at 50 Pascal test pressure. The bottom three are all different versions of commercial compliance for air barrier testing. So good on most people for getting that right. Moving on. Our next section is the 2018 IECC Commercial HVAC section. Again, in our full-length presentations, we cover 10 different items that we considered the top 10 issues for compliance or issues that we see when we go out and check buildings for assessments. What we wanted to cover today specifically were Economizer fault detection and diagnostics, since that's new to the 2018 IECC, and maintenance info and system commissioning, mainly focusing on commissioning because the 2018 updated their language for a lot of control systems, saying that instead of being just capable of certain controls, they now have to be configured and working when the building is turned over to the operator or to the owner. So first we'll look at Economizer fault detection and diagnostics. For air-cooled unitary DX systems listed in the tables in the IECC, where they list efficiency requirements, and VRF units. They're required to comply with this Economizer fault detection and diagnostic requirement. The previous code, the 2015 IECC, simply stated that systems had to be capable of doing fault detection and diagnostics. The 2018 did upgrade that language and says that these systems must be configured to do this now. Those systems have to be able to monitor supply and return and outside air temperatures, different system operations, whether cooling is active or not, whether the economizer is active or not, report on what percent those damper positions are at. So various details, and it should be able to detect any control issues and report back to the operator when there is a fault or some kind of error. What you see here in the image is an example for a small DX system that has an economizer installed on it. Say it's a residential unit with an outdoor air damper connected to the return. It just has a readout on it for that economizer damper in that outside air duct to that furnace that reports whether there's a fault or not. It highlights that screen. You press on that screen and it tells you whether it's a sensor error or should be economizing and not. So that's one compliance method. Another method, very common for systems, is RTU systems. These are DX units most commonly. It's common for these to be set up, and especially on older units, you had these older gray boxes that you see in the bottom left. And it's hard to tell whether that's set properly or not because there's no readout and no clear distinction of what those settings mean. You have to go find the owner's manual. Okay, A means that it's set for a dew point. So it's hard to tell whether those are calibrated, set up properly. Newer RTUs and advanced RTUs will have the orange boxes, just as an example, but it'll have a digital readout of what the settings are. So you can easily scroll through the settings on it and see whether it's configured properly for your region, and whether those settings are going to work properly. The other way you could do compliance with the Economizer fault detection and diagnostics is through BAS trend data. A lot of BASs have the capability to report back to an operator using logic that's programmed into them, whether there's an error with the system. In this case, in the image, it's indicating that it's cool enough outside to do free cooling with the damper fully open, but the damper is not opening enough and the cooling valve is coming on, or some error such as that. And so it's going to report back that there's a problem. There's adequate cooling capability with the outside air alone, but the cooling valve is still opening for some reason. But in all these instances, there just has to be some means of your economizer system to report back to the building owner at a centralized location that there's an issue with that economizer that's not working properly. The reason this is such a big deal is if that economizer gets stuck in an open position and you draw in a lot of outside air, that is a lot of excess energy that the building is going to be consuming that they might not even necessarily know ever happens, because the system may be able to, most of the time, keep up with those loads and provide comfort to the occupants. It's just going to use a lot more energy to do so. So that's why this fault detection and diagnostics is an important part of the code. The next thing we'll get into is maintenance information and system commissioning. The 2018 IECC changed a lot of language again from capable to configured and operating. Thermostat bed bands, occupied setbacks, unoccupied setbacks, equipment modulation, temperature resets, the economizer fault detection we just covered, demand control ventilation. There's a lot of different control systems in buildings now. Even lighting and things are brought into automated controls, all trying to bring down the overall energy consumption of the building through automated means. If any of those aren't working properly, it can result in a lot of excess energy consumption for the building, or discomfort for the occupants that they then go and try to tweak the thermostat settings or change other things. If these aren't working right, it's a lot of extra workload on the maintenance operators. Unfortunately, what we see a lot of times with construction, since commissioning happens at the end of the project, right before turnover to the owner, a lot of times with tight budgets or tight timelines, commissioning gets reduced or removed from the budget and doesn't get completed properly. And so it leads to a lot of long-term problems. And you can kind of see in the image here, the guy's hot in one corner, someone else is cold, someone else has got a fan blowing on them, people are fighting over the thermostat settings. I don't know how many of you have seen that in your own offices, but I know I've seen it in a number of places that I've worked. So we'd like to avoid that through commissioning if possible. We did a little research on what people have found as far as what the energy and cost savings of proper commissioning can be for the buildings. ACEEE reported anywhere from 25 cents to $1.25 per square foot for commissioning costs. Lawrence Berkeley report actually found that somewhere around 18 cents per square foot per year could be saved at a cost of about $1.16 per square foot on average from a national study, which that pays back relatively quickly, somewhere around 3 to 5 years. But the other benefits it has is it improves building durability, prolongs service life, reduces callbacks to the contractors for issues, reduces calls to the maintenance staff. reduces comfort complaints from the occupants. One example from our experience in the field, we had a school. They had HVAC fans that turned off on schedule at night, but there was an error in the program logic that kicked the fans back on at midnight instead of 6 a.m. the next day. So the system ran for 6 hours overnight with no one in the building, and resulted again in a lot of excess cost for that client. As far as how to get compliance with system commissioning, how to let your authority having jurisdiction know that that's been done, a registered design professional or an approved agency needs to document what the commissioning plan is and how commissioning is going to be performed, and that commissioning is being completed, and that some amount of the requirements should be included in your construction documents, and that plan and documentation gets provided to the code official along with to the building owner. And we'll touch on this again. Usually we touch on it again in the lighting section on how to make sure you got compliance documentation for commissioning. So now I'm going to hand it over to Ryan so he can cover our commercial lighting section.
Well, thank you, Sean. So here we're going to touch on two things, starting in the lighting area, occupant sensor controls, as well as some functional testing. Again, this commissioning comes back into play to make sure that systems are working as designed. So that way the building owners are getting the value that they've paid for as part of construction. So starting with our occupant sensor controls, I will try to be cognizant as far as using occupant sensor controls rather than occupancy sensing controls, because both occupancy sensing and vacancy sensing are both occupant sensing methodologies. So right off the bat, we call out that automatic shutoff is required in nearly every space. So this could be done either with occupant sensing devices, time switch controls, or a combination of both. The code does have language in there that allows for you to use occupant sensing devices in lieu of time switch controls for areas that the code states needs time switch controls. However, it does not go the other way around. So if the code calls out that you need occupant sensing devices, you can't use time switch controls to meet that requirement. So going into as far as what those requirements are in the space types, the code added one new space type, which was open plan office areas. And they've also clarified for warehouses that it's specifically the storage areas. So the office areas in the front of the warehouse building would probably be included in some other area, but the warehouse storage area has specific requirements. So as far as how the code is laid out, they go through two different types specifically. First is the house storage areas, the second being open plan offices, and the third is all other areas. So starting in the warehouses, this requires at least 50% reduction in lighting when occupancy is not detected by the occupant sensors. And with this, we need to control the open bay areas towards the front of the illustrations here, separate from our aisleways. Again, and each aisleway needs to be independent of one another. So if we have someone picking items in one aisle, we don't need the lights on in the next aisle over from them. So there's a few different thresholds that you'll see throughout this. So here, again, calling out at least 50% reduction when the occupant sensors are detecting no more occupancy in that area. So next, moving over to open plan offices. This has specific requirements as far as our zone size limits of 600 square feet. And then these next two requirements kind of go hand in glove here. The first being that we have to reduce the lighting power by at least 80%. So whereas warehouses, it was 50%. Here it's at least 80% for any particular zone when that zone no longer is detecting occupancy after 20 minutes. And then the next requirement is you have to turn all the general lighting off in all the zones once there is no occupancy detected in any of the zones. So how these two can typically be accomplished, either you can have each zone control independently and turn off 100% of the lights in that zone, or you have to have a system where the zones are tied together so that the system can determine if there's no occupants detected in any of the zones. So those two kind of go hand in hand with each other. Frequently, we'll see, more commonly, we'll just go ahead and turn all the lights off in a zone to reduce some of that complexity, which again, if you have complexity, makes commissioning harder. So this fourth point here, noting that the daylight responsive controls should not be overriding the occupant sensing controls, because we don't want all the lights to turn on once it gets dark out if there's no occupants to have the lights on. So the occupant sensors have first call of the lights, and then once the lights are on through the occupant sensing devices, then the daylight responsive controls will do the dimming and control on that. So with that covering the warehouse areas and the open plan offices, now we get into everywhere else that is not those two. So here, noting the auto off within 20 minutes of occupants leaving a space. Previously, in the previous code cycles, that was 30 minutes. So this is a reduction. Also, it's noting that this can be manual on, or if it's auto on, it cannot bring on more than 50% power. So manual on typically would be called vacancy sensors, where auto on would typically be considered occupancy sensors. So that allows occupants, as they enter the room, to either determine, do I need lights at all, or if they walk into a space and the lights come on to 50% power, the occupant can choose if they want to go ahead and bring it all the way up to 100%, or maybe they prefer it at 50% is fine. The code does provide some exceptions for the auto on to allow lighting to come to 100%. So here noting corridors, stairways, restrooms, and other potential safety issues here. So something important here is being able to have manual control so occupants can turn lights off. Had worked on a previous project in a library that they had added occupancy sensors, and you know, these were going to be great energy saving devices, which they were. The challenge became in rooms where they were study rooms, and when people would go to try to use displays, there was some too much light in the room, and they wanted to turn the lights off. There wasn't any light switches for the occupants to turn it off to be able to see the monitors. So very, very important to have that ability for the occupants. So as far as functional performance testing, so here we're getting into commissioning. The code calls out that we have to commission 3 different types of lighting controls. First being occupant sensor controls, second being time switch, and third being daylight responsive controls. So with this, you know, the more controls we add, the more complexity we have, and the more chance of things failing. So with the documentation of this, notes similar to the HVAC controls, that the construction documents need to include specifications for commissioning. And it also notes that the manuals and the report need to be provided to the owner within 90 days of the certificate of occupancy. How we have seen some jurisdictions handle this, because jurisdictions typically don't have any real interaction once the certificate of occupancy has been issued, is requiring a letter from the building owner acknowledging that they are to be expecting this documentation. So at least the building owner's aware, and if they still don't receive it, then that the building owner has the ability and knowledge to go to the contractor and design team to request it. So moving on to what we need to be testing in occupant sensor controls. We have to be testing every space geometry and sensor combination. So it's not uncommon that this is going to be requiring testing of nearly every space, because different geometries, so you might have two conference rooms that are mirror images of one another. That's still a difference of geometry. Where you might be able to do more sampling is if you have, say, a stack building where every floor is the same. So, and it does go through several different things that have to be verified for each sensor location. So, time switches are a little easier to do, as far as there you're testing the programming and verifying that the schedule is in there. An important thing is that making sure that there's a documentation of the initial schedule and setup, such that in the event that the program gets lost, the time switches are required to be able to maintain their memory or their functionality for at least 10 hours after a power failure. But in the event you have an extended power failure or something gets corrupted, having that documentation of the initial setting is crucial, so the building management can reinstall the program appropriately. So just a lot of different verifications here, making sure that the override time is limited to either 2 or 10 hours, depending on the space type. Control switch operations, as well as verifying that the battery or other backup power supply is functioning. So next is daylight responsive controls. There is a way and methodology to avoid requiring daylight responsive controls. There is an exception back in the daylight responsive controls area, where if you reduce your lighting power budget, then you can avoid needing daylight responsive controls for the building. So here again, noting there's several different things that we're looking for as part of commissioning. You know, is each one working properly? The other side of that is the calibration equipment readily accessible to authorized personnel, not necessarily to the occupants, but you know, the building maintenance people have to have access to calibration equipment such that they are able to recalibrate if the system changes or has some issues. So that's a real quick run through as far as some of the commercial lighting provisions.
I did
So
want to
moving
touch
over,
on, there's a Q&A question about for compliance documentation, does that come from the engineer of record or the commissioning agent? The code allows either, it just has to be an approved agency or the engineer of record. So usually what we see is a combination of the two. The engineer of record will have commissioning requirements listed in the documentation, the plan documents. The commissioning agent will then document what the commissioning procedures are, what the plan is to actually test each of those systems, and provide that documentation back to the engineer of record and the building construction team, so that commissioning can get done.
Uh, Looks like there's, yeah, have another question as far as commissioning. As far as the code calls out several, the aspects that have to be done. As you may have observed on those lighting slides, it goes through and documents, here are the following things that must be verified as part of that. And then the commissioning plan would detail out how you're going to go about achieving this. All the different checks that need to be done, uh, the spaces that need to be covered. So for lighting, it's likely to include a listing of every single room, and then identification as far as which checks need to be performed for each room, so that as they go through to commission, they can check off each one as they document it. So verifying it as you go.
And it's very similar for the HVAC system. For each component of the system, there's going to be a functionality test, essentially, that's going to verify that system's working properly. And so that plan gets developed, and that plan needs to be presented somehow to the authority having jurisdiction, so that they can verify that these systems are going to be tested and verified to be working properly.
So, commissioning is a big area as far as trying to go through and verify that everything is functioning correctly as designed, particularly as we get more complicated systems that might have things that are crossing boundaries, occupancy settings, along with HVAC controls, dew point controls, and the like. So we go through, there's a lot of verification for commissioning now. So that's part of the reason why I mentioned about the daylight responsive controls, how there is an exception to allow you to not have to purchase, install, and maintain them and commission them. So by doing improved design, you can avoid some of the headaches and hassles of commissioning. So
We did have a question in the chat. What percent of buildings are we seeing that aren't commissioned properly? And that's kind of hard to tell. I know in my experience as a on-site building commissioning agent, I worked in existing buildings. So my view is a little lopsided because you have ongoing maintenance issues and things that cause commissioning problems. Although I did run across one new construction building. It was a chilled beam research facility. And the building was so complex that the commissioning just couldn't be done. They were trying to do it piecewise, couldn't do it all together. There was very unlikely that was being commissioned properly. So as far as what percentage of buildings aren't commissioned properly, that's really hard to answer without some in-depth research.
Yeah, and that is one that commissioning, when the concept of commissioning came out just in fairly recent, as far as construction goes, fairly recently, commissioning has been increasing as far as visibility and understanding as far as value, because previously the consideration was, well, the systems were designed, so why am I paying someone to prove that I got what I paid for? I paid for it, didn't I? And so, that is something where I would say that we've definitely increased from 0% of the buildings being commissioned. But yeah, as Sean noted, there's not really solid numbers at this time. That is something that the code has been pushing much harder in acknowledging that has a bigger impact. So do have a few more questions coming in, but we'll keep pressing on here to make sure that we're staying on time. As far as residential goes, talk about the residential energy certificate fairly briefly, and then get into additions and alterations. This will be on the residential side, but many of the provisions also fit with the commercial side too. So as far as the energy certificate that's required, so again, this has been required for about the last 10 years here in the state of Illinois. Uh, and it notes that several of the features that need to be on that certificate, and that needs to be posted either where the furnace is or an approved location. This would be approved by the building official. Typically, a commonly approved location is on or adjacent to the home's electrical panel. So the two common places that we find this is either in the furnace room or the electrical room. So obviously we don't want to cover other required labels. Details out several of the aspects of this. So next here we see some examples of building labels. So if I there's many other formats that this can be in, but here are two templates. So if I received this certificate on the left, I'd be a little bit skeptical. Now this is based on a previous code edition, but all of these values are exactly the code minimum. So the fact that the blower door test and the duct test came in at exactly 3 ACH and 4 CFM, I would be fairly skeptical of this label. However, the importance of having this label, and it could be something where you, even for existing construction that may not have been required to have these, you can go back and generate them frequently. So an important aspect to having these is things such as the U factors for windows. In the event that I break a window down the road, understanding as far as how good of a window do I need to make sure that I replace, because the little sticker that comes on the windows, they've been long gone. So another aspect of this is if I look in the attic and I find, I have an R50 insulation, I know that the attic has been improved from its original condition, which could impact my heating and cooling equipment sizing. So some things to consider as far as, have things changed over time, or if something breaks, what might I need for that? So as far as additions and alterations, this is where the real challenges become, because frequently we are dealing with buildings that were built before there was an energy code. And even if that's not the case, energy codes have changed and frequently improved with time. So what we call out here is that the code language is very important as far as how it specifies this, but noting that an alteration cannot reduce the code compliance. So if for example, a roof has R20 insulation and the code calls out R30 now, you cannot go back with anything less. At a bare minimum, you can't go anything less than R20, because if you went back with R15, that would be less code compliant than you already were. So you can't diminish the energy performance of a building. So next up, we've got several exceptions as far as things that are not required to comply. Call out a few items on here. Number 2, so if you expose ceiling, wall, or floor cavities during construction, you do have to make sure that they are filled with insulation. That doesn't necessarily mean that you have to bring it up to the full present value listed in the table. As long as you have filled the cavity with insulation, you're fine. So if you open a cavity and it's already insulated, then you're done. It's filled with insulation. The other thing we note here is item number 4, roof recover. Noting here, see definition. Roof recover is you are putting a new membrane over top of the existing. So that is without removing the existing membrane. You're just putting a new cover over top of the existing. So we do note those two here. In the next here we have some photos of potential alteration exceptions. The first being, I've added some storm windows. I've also, potentially adding some window films. The lower left here, you see we've exposed a cavity, and so that gentleman is filling the cavity with insulation. So even though that may not meet the full R value, he is just filling the existing cavity. The lower right here, we have illustration of previously plastered walls with just some furring. Here, if you had pulled the plaster off, that does not constitute a cavity with just strapping. But something that we have identified as far as if you wanted to go back with insulation, because this is a mass wall, and using the U factor tables, you're able to just install a 2x4 wall with an R13 insulation, since this is a mass wall, and that would allow you to meet a full U value for new construction. But yeah, so here we don't have any cavities exposed, so I wouldn't be required to add insulation, but it would be good practice to go ahead and do so. So next up, we have an Illinois amendment. This is something it is rarely likely to apply. And so this is similar to a recover, but here for a peel and replacement, states that the roof membrane peel and replacement where an existing weather-resisting roof membrane alone is removed, exposing the insulation or sheathing, and only a new weather-resisting membrane is installed. So under a roof recover, I've left the existing membrane in place and placed a new one over top. With this one, it's saying you peel the old layer, the old membrane off, and you put a new one on. So, and that's it. That is the extent of it. So this is not likely to apply because we have seen very rarely is a low slope roof membrane replaced before you ever have a leak. And if you've had a leak, you've likely damaged the insulation and or the structure. So that requires you to, or would require you to repair that insulation or sheathing. So as far as what do you do when you come across this? The challenge becomes for the city of Chicago, they have written a specific amendment for this. For the rest of the state of Illinois, you have to read a couple of different provisions and take it together to accomplish the same thing. So for the city of Chicago, noting that if you can't meet it due to flashing height limitations, you have existing conditions that are not being altered, then you have to go back with what you can. So how this applies, and I've kind of underlined how this ties together for each one. So for the city of Chicago, noting in no case shall a roof replacement reduce the R value of the roof assembly. For the rest of the state of Illinois, alterations shall be such that the existing building or structure is not less conforming than it was before the alteration. So you can't reduce what you had. So next up, we'll take the first portion of this, city of Chicago. And so noting, hey, you have to, acknowledging existing conditions may prevent you from meeting this requirement. So what that looks like in the Iecc is alterations shall conform to the provisions without requiring unaltered portions of the building to comply with this code. And the alteration shall not create a usage or hazardous condition or overload the existing building. So what this, and that's where the city of Chicago text kind of lays out what that actually means. And this is how this has been observed across the state of Illinois and interpreted for consistency, is noting that if you have a parapet wall that if you were to add more insulation, you'd have to raise a parapet wall, or you'd have to raise and pick up HVAC equipment. Well, HVAC equipment is not part of the roofing system. So what this states is you have to bring it up to the best you can without requiring you to alter other portions of the building. So the only piece on the next slide here that City of Chicago calls out that is not required by the IECC is City of Chicago states that the insulation must have a minimum of R5 per inch. So that's where these two, it's nice that the City of Chicago has this amendment that spells it out. However, the IECC does have provisions that effectively provide the same benefit for the rest of the state of Illinois. So regardless of where you are in the state of Illinois, the real objective here is you have to do the best you can within the existing constraint that you have. Now, if you were to be replacing a roof while at the same time replacing the rooftop unit that's on that roof, because you are now making the HVAC part of the alteration, that roof curb for that rooftop unit that you're replacing would not be considered an existing condition. So there may be other rooftop units on the same roof that are, but that one that you're replacing would not be part of it. So I think with that, let me pop up a poll question here. Oh, here we go. So here, looking at if I need to repair or replace insulation or roof decking, can I still qualify for the peel and replacement under the Illinois amendments? So yes, no, or if I can sneak it by the inspector. So
while we're answering that poll question, one came in the Q&A, expectations for correct installation on cathedral ceilings.
for cathedral ceilings, this would be, it depends on if it's new construction, the requirements are likely to be a little bit different than if this is cathedral ceiling during a renovation. Cathedral ceiling for new construction, you would refer to the tables in the 2018 IECC book. For your ceiling insulation, which again, that'll depend on if you're residential or commercial. So if it is existing and you open a cathedral ceiling, the cavity must be filled with insulation to meet compliance. So
for new construction cathedral ceilings or ceilings without attic spaces in them, there is an R30 allowance for that ceiling cavity, since it's not going to be able to fit full depth insulation for our climate zone. Usually the framing stuff only allows a limited amount. But of the total ceiling area, the ceiling area allowed to have that R30 insulation has to be 500 square feet or less, or 20% of the total ceiling area or less. So there are limitations on how much of the ceiling can have this lower insulation requirement if it's a cathedral type ceiling.
okay. So here we've got, interesting, a little bit of a split here. So as far as our poll question, noting, you know, if I have to repair or replace insulation, can I still qualify for peel and replacement? A little bit of confusion here, so might not have covered this quite right. The correct answer is no. If you need to repair or replace insulation or roof decking, you do not qualify for peel and replacement. So the only way to qualify is you have to only require remove the old membrane and put a new one on, and that's the end of it. So yeah, so a little bit of confusion, but yes, if you have to address insulation or roof decking, you are not under peel and replace. So
we want to thank the AIA Chicago chapter for promoting our workshop, and we hope that you can attend our full-length workshops in the coming weeks, get a little more detail, maybe get a few more of your questions answered. But again, thanks for having us, and hope you found this useful. give it a few more minutes in case there's any more questions. If not, then thank you for your time, and hopefully we'll see you at our further workshops. We did get a question, who enforces compliance with the energy code? Ryan, you want to cover that one?
Sure. Enforcement of compliance with the energy code is your local building official. That is triggered by application of the building permits. So when you apply for the building permit, that will provide some, that will trigger the required reviews for energy code compliance. So yes, it's enforced by a local jurisdictions. The energy code is one of the few codes that are adopted on a statewide basis. The energy code, life safety code, and the accessibility code and the plumbing code. Those are the four that are adopted by the state of Illinois. So as far as credit and certificates, we will be emailing out certificates here before long for AIA credits and ICC credits. When we email out that certificate, if you would reply back to that with your member number, and we will go ahead and get those filed with the respective agencies.
Some common techniques for energy modeling apart from ComCheck. ComCheck isn't really a full energy modeling program. It's just taking the prescriptive requirements in the code and verifying the U-factor tables to the U-factors you put into the program. But as far as energy modeling that we see most frequently is probably Energy Plus or one of the DOE engines. Such as Equest or something, but Energy Plus seems to be the primary one most people use now. But there's also individual companies. Train has a program called Tracer. Carrier has the Carrier HAP program. So there are some company-specific programs as well that are used for modeling that we see frequently.
Yeah, and as Sean brought up, yeah, ComCheck is not an energy model. That is actually part of the prescriptive path. It is not a performance path for the ComCheck.
All right. Well, thank you everyone for attending.